Hi, so for the last experiment, pretty much from the safety perspective, all I had to do was make sure I don't point laser towards my eyes. And other than that, just don't eat the Skittles. Those are the only two safety precautions I followed for this experiment. Of experimental design, I used the box over here for, as you can see, the markings of the gratings and everything, to set up my diffraction, grating, and laser. Uh, and I used it that way. CD and flashlight was straightforward. Instead of book, I used a duct tape to elevate the laser on the point, and for the Skittles, there was not much experiment setup required for at all. From the results perspective, this could take a while. There is less light here, but okay. So for the first part, as I can just quickly portray it right away. Okay. So as you can see, there is different lights you can see around, and that's about it. The different spectrum that you can see. The reason why you can see this spectrum is because this is white light. White light contains all the wavelength. So most of the light is being reflected black, and actually if you see, it's pretty much the same as the natural lighting coming from the outside is falling on the CD, so we could pretty much see the same spectrum. On the other hand, when you do the same with the laser pointer, the only thing that you can see is that you can see laser being reflected across multiple places. I can see some part over here, some on my hand, some outside, and so on and so forth. We can still see some spectrum while pointing the laser. That is not because of the laser, it's because of the natural lighting that is coming from outside. So this is the explanation. This is a spectrum that I drew. This is how the laser was falling onto the CD. For the diffraction grating, the grating was about 8.2 centimeter. The distance x, which is from the center dot to the first dot on either sides, and the length from the first dot to the grating was about 12.5 centimeter. So when I calculated it, it turns out to be roughly 656 nanometer. This is how those 5 dots looked. I just showed you on the screen. And when I replaced the laser light with the flashlight on the kit box, I could see nothing on the white background. But if you look carefully, you would see some spectrum being generated in the form of the circle, as I've drawn here. And some colors, and all the colors are being shown but that is being seen on the grating, not on the white box or the kit box behind your grating. Now for the second experiment, this is the table that I've done. So for the first time only, I got about 38 daughters down. So 23, I had to put it back, and it gradually decreased. To show you the graph, I have created this graph, which is the fraction of the cumulative daughter divided by the parent on each trial. So it took about 8 trials since we started. I included 0, but after 0 it took about 7 trials, so it goes from 1 to 8. And this is a graph. Now coming on to the critical part, why did the spectra from laser light differ from, as laser light is monochromatic, so it has only one light. So when you when you put that light on the CD, what essentially happens is Since the laser light is monochromatic, none of the light is being reflected back, but the flashlight is very bright radiation light, which contains a wavelength of all the lights. That's why you could see the spectrum on the CD. What is predictable about radioactive decay and what is unpredictable? Okay, so for the predictable part, I would say it is predictable the half-time decay of the radioactive particle, but it is the unpredictable part is that how long will it take for the molecule to go completely. That is how long it will take for a particular molecule to decay completely. So that's for critical thinking. On the reflection, self-reflection, most useful lab activities for understanding the content. Initially, for the first couple of experiments, I know since it was mostly getting used to doing the lab experiment at home, but I think I really enjoyed calculating the amount of calcium out of calcium carbonate, where we had to heat the material and use the sterno. So that part was pretty fun for me, supporting your understanding, most useful in supporting your understanding of the content. So here I would say mostly the textbook is pretty much at the point, and everything I need to know for this lab or for this course is pretty much there, and even lab procedures are pretty straightforward. So I think these are very supportive. Growth with laboratory technique and chemical safety, most useful in supporting. I think the lab procedure is fairly sufficient, but I think what lacks here is maybe next time you could provide us you could provide the students the SDS that you want them to refer to, rather than them finding online, because many SDS have many different things. Most of them are same, but somewhat it's confusing when you read one SDS and then you read the other SDS of the same chemical. Least useful for supporting lecture content. I couldn't think of anything that is least useful, because the only thing that we used for lecture content was the smart work file and the textbook, which is pretty much, I enjoyed them. I like to go through it, and it helped pretty much on every quiz. Most, I think, from the laboratory perspective, the only lab I would say which is least useful for supporting the lecture content, I think would be the Skittles. Is I was looking towards the nuclear chemistry, but this is more like, it turns out to be a game of probability rather than the nuclear chemistry. So yeah, I mean, it does somewhat portray the picture of the radioactive decay, but nuclear Skittles is not necessarily how you would want to do or perform radioactive decay experiment. But again, I understand, since radioactive decay is pretty much harmful for us, and maybe that is the reason why we chose a safer method. Least useful for supporting the development of your laboratory skills. I think laboratory skills is mostly you would get used to it after 2 or 3 experiments, and after that you'll just get a hang of it. And yeah, probably one thing that I would like to point out is that the molding clay that they provided us was pretty messed up, or probably I don't know how to use molding clay. Other than that, I think this course was pretty fun, and I had fun. And that's about it for this one. Thank you.